Okay. Okay, this is Martin Crawford with ECS, and I'm here today to go through a training of the odor control system here at the pump station. What I'd like to go through is the topics we'll go through is basically the technology, the components of the system, and then through the safety. So basically, if you're looking at the system here, what we have here is a local control panel that is basically going to be controlling our fan. Our fan is basically just in a local off or remote position. Remote right now I don't think is hooked up to anything, but I think in the future you'll be able to hook it up to SCADA and remotely turn it off and on. So right now we operate in a local mode. Once you turn the switch local, it starts the fan up. It's pretty much set to do anything. The only warnings or shutdowns we would have on the fan here is basically if the fan had overampage, and you'd basically get a fan overload alarm. And also, I'll show you here in a minute, we do have a flow switch or flow transmitter on the back. If the flow were to drop below a certain level, we would also shut the fan down. So that's pretty basic operation onto the system. As you see here, basically what we're going to be doing is drawing air from the wet well through a pre-filter into our fan, which is located in the sound enclosure here, and blown into the carbon system. The technology here is basically just activated carbon. So it's kind of like your water filter or anything like this, is that we have activated carbon pellets in here, and as it absorbs the odor, we have odor coming into it, it absorbs it, and we have clean air going out through the stack. The carbon will continue, or the system will continue to perform until the carbon gets saturated, and then it'll have to be replaced. And we'll go through that here briefly in just a minute to show you kind of how that's taking place. Most likely you farm that out, but we can kind of go through basically how that is. So let's go on the back side, and we'll walk through the flow process here and the components, and then we can talk about each one specifically. Okay, so here's what we got here. Basically right here we have our inlet ductwork that's pulling the air over from the system into this big box here, which is basically a pre-filter. There's a mesh pad in here that's going to take out any particulates, greases, or anything like this into it before we go into the fan to help protect the fan and the carbon vessel. The carbon vessel works as a good filter for these items, but we want it to take care of the odor, not the particulates or greases or any other type of material on that. It flows into the fan, and we'll open up here and show you the fan here. Basically, it's just a fiberglass fan inside the sound enclosure. Then the air blows tangential, and as you can see, this thing is, the inlet here is kind of a tapered tangential. This is what we call a radial flow carbon system. So if you were to cut it in half, you look down onto it, it'd be a donut carbon of it. So the air flows around outside it, what we call radiates through the carbon, and then out through the stack at the top onto it. So this is what we call a radial flow system. That's why it has that weird tangential inlet to it on the thing. Maintenance items pretty much that we're going to be dealing with here is a couple items. Is we need to keep an eye on the differential pressure on the pre-filter to make sure it's not plugging up. And we can come around here and I'll show you where the gauge is here. There's a gauge located here, and we have a mark on here that will show when we need to kind of start taking cleaning these filters. These filters are just stainless steel and poly mesh pads in here. We have an access door here where this can be taken off and they can be cleaned with a pressure washer with some soap and then put back in and retained. You can also, if you needed to, get an extra set so you could swap them out. But when this gets up to the mark on here, right now we're sitting at about 0.25. Once it gets up to about 0.5, doing is looking at cleaning these pads out because we've gotten buildup onto it. When we then come into the fan, we'll talk briefly about the fan maintenance. You guys have a lot of fans in your district out here or county. Belts and bearings are the main thing. We want to grease the bearings once a quarter, and probably every year and a half, we're going to be changing out the belts. We'll go inside there and look at the fan briefly to kind of show you where the grease points are and where to change the fan out of. We then blow out through the fan here and tangentially into the vessel. Now, we do have a differential pressure gauge here on the carbon vessel. It's more indicative of, since we're not really putting anything in it that's going to plug it up, it's more indicative of airflow, but you do have an airflow transmitter I'll show you in a little bit that basically will tell us the airflow. So this really doesn't really give you a lot of information onto it. but it does tell you a little bit of the pressure drop. We have two sample ports here. Here's the inlet sample port if you need to measure the amount of odors going into it from your pump station. And here's a sample port coming from your stack, so you can measure what's going out through the stack if you ever need to take any type of reads or analysis onto the system to look for where the odor is. We do have one more gauge here. It's a little bit different. We have this gauge here that's basically measuring the pressure of the fan. It's hooked up to the inlet and outlet of the fan, so the fan on the inlet will be negative, this will be positive. So this just kind of gives us indication as far as if the fan's putting out the right pressure. More important, we have a flow transmitter over here that I'll show you that's going to be more indicative of basically how our flow is. And I believe that you're getting your readback on your SCADA system so you can make sure your fan's operating properly onto the system. Okay. Your flow transmitter is here. It's in the ductwork here, and it's telling us how many cubic feet per minute of air is coming into the system. And I believe, like I said, I think you may be getting a readout eventually into your SCADA system so you can monitor performance of your fan and make sure it's operating properly. This is also giving you feedback to the control panel that if the flow drops below a set point in there, it's going to relay and shut the fan down, letting you know there's a problem, something's plugged up, the fan's thrown belts, it's seized up, or had problems onto the system. So that's going to be your major indicator that I have a fan problem is from this flow transmitter. And the flow's given here. We're moving 8,500 cubic feet per minute of air. And that's basically, if you come around the other side, we can take a look at the readout here, and it's showing about 8,500 cubic feet per minute of air being pulled from the wet well onto the system. And maybe let's go take a look at that, and we can take a look at the fans. So right here, like I said, it's showing just over 8,500 feet per minute. Or 8,500 cubic feet per minute of air going into the system. That's basically what our design is and what we are running our fan at. We do have an adjustment on the fan outlet. There's a damper that you can adjust this airflow and everything, and we can take a look at that when we go back around over to the other side. You should never have to mess with this. It's a constant speed fan and constant setup. There's no VFD, no flow changes or anything that we need to be making. So you shouldn't have to adjust that damper over there unless you're changing the fan out or doing some major reconstruction on it, on the thing. But I can kind of show you where that is and where it's set. Oh, let me hook this back up. Show off this. Okay, as we mentioned, here's an airflow control damper. It is set and locked into place. You should never have to mess with this. This is basically what's regulating our airflow through the system onto it. I have it marked on the top, and it's bolted and locked into place so that you should never have to mess with it. So don't be messing with this because it'll mess up the flow. If you open this up, we're going to get a lot more airflow into the system that's designed. If you pinch it off, then again, you're not going to get the airflow on it. So this needs to stay the same throughout it. One last thing I have here is I mentioned earlier that we have this exhaust air sample port that comes out of the stack. We have a visual monitor here that basically is a green tube that basically will turn brown or black once you start getting breakthrough that your carbon's exhausted. So this will tell you that, hey, I need to change my media out. It's gotten totally absorbed, and basically it's no good anymore, and I'm going to get odors coming out my stack. So once this changes color, this is a visual indicator that I need to change out my media onto the system. Now, for changing out the media, as you can see, we got handrails and guardrails. So we can come around over here and look real quick. Okay, at the top here, we have ladder and safety harness connections. At the top, there's 3 manways there. They're crescent-shaped manways. You can take that off, and that gives you access into the media beds. Typically, when the carbon's changed out, you will take those hatches off, get a vacuum truck and vacuum out, and then you load the carbon back into it, usually through big dump sacks, to 2 kilowatt type super sack type thing that's dropped into the material, into the retaining screen. So like I said, if you looked in it and pulled the hatches off, you'll see that it looks like a donut. You'll have an airspace on the outside, donut full of carbon, and then a collection center in the middle where the clean air comes out and goes out through the stack. Okay, the last thing we want to talk about briefly is basically the fan. The fan's housed inside this sound enclosure so our neighbors don't hear it running all the time. We have access doors in here. A little hard to hear, but basically we have fan belts here that need to be replaced about every year, year and a half. And then there's 2 grease points looks like they left you some grease in a grease gun. There's 3 zerk fittings here on the top. I don't know if you can see it here, but those need to be greased quarterly on there. It tells you the type of grease that needs to be put onto it, and they need to be greased on a quarterly basis in order to keep the bearings. The first 2 are for the two shafts, these bearings for the shaft, and the third one is the shaft seal to seal it from the housing on the inside. The big thing is keeping your bearings greased and lubricated quarterly, that you need to be given those 2 or 3 shots of grease, and then replace your belts as needed. Like I said, usually typically a year, year and a half on those. If you do that, this fan should last for a long time. Everything's fiberglass and corrosion resistant onto the system. You shouldn't have any type of problems with it. Basically, that's the only thing you need to worry about. The only other items I saw over here real quick we'll look at is that there is a drain on this vessel. If for some reason you get condensate or water into it, you can open the drain and drain off any type of excess moisture that may be collecting in here. It's kind of stuck. Well, it won't break it off, but you can open up and get the excess moisture out of there if we get it down there. Typically, you shouldn't have any rain coming in. The stack is a no-loss stack. As long as the air is flowing, no rain will get in. Now, if it looks like you're going to have to shut the fan down for any amount of time, you need to probably put something over the stack so that we don't get a lot of rain and moisture coming into the system. The only other thing you need to keep an eye on, if you're changing out the belts on that fan, you do need to probably close off the damper so that your fan does not rotate or spin when you're trying to change the belt out for a safety issue. That's the biggest safety issue that I have to mention here, is that if you have to change out the belts on your thing, you can close the damper on there that I showed you earlier that sets the flow, so that you don't get any airflow through it and your fan doesn't spin when you're trying to put the belt on. Then you need to set it back to its set point on there, and then you can start the fan back up after you change the belts out. For the most part, that's all I have to say on the system. It's pretty simple. Keep the fan running, keep the correct airflow, keep your pre-filter clean, and just change out the carbon as it's needed depending on the amount of odors that you got into the system.